Well, good morning. This is lesson number 13, pre-algebra. The stuff this week you're going to find is going to go pretty fast on this video. The first part is lesson 13 talks about this thing called greatest common factor, or Gaucho Christian Fellowship. If you go to UC Santa Barbara and you want to go to a Christian club, that's what they call themselves, GCF, greatest common factor. If you think of this backwards, factor, common, greatest, that'll actually help you figure this out. So what they're asking is, let's say, for example, you have a number 12 and you have a number 30, and they say, what's the greatest common factor? Well, this is what you do. You factor it. Remember the prime factor trees? 2 times 9 is, or 2 times 6 is 12, and then 2 times 3 is 6. So the greatest, so 2 times 2 times 3 is equal to 12. Okay, 30 is 5 times 6. 6 is equal to 2 times 3. So 30 is equal to 2 times 3 times 5. Okay, so if I say what's the greatest common factor, I factored it. What's common? Well, 2 and a 2 is common. Sorry, a 2 and a 3 is common. There's a 2 and a 3. And that's what's common. So I'm going to now the greatest, that means what's 2 times 3? 6 times 2. And 30 is equal to 6 times 5. So the greatest common factor is 6. Okay, it was a little confusing in my explanation, but I'll do a couple of these and it'll make a little bit more sense. So let's say, for example, I've got a problem like, what's my greatest common factor of 18 and 60? So I'm saying, what's the biggest number that goes into these? Well, I'm going to do it this way. 18 is just equal to 2 times 9, which is 3 times 3. Okay, I don't have to do the tree if I do it in my head, but doing the tree is fine. 60 is equal to 2 times 30, right? And 30 is 2 times 15, and 15 is 3 times 5. So 60 is equal to 2 times 2 times 3 times 5. 2 times 2, 3, 5. Okay, what's the, that's, I factored them. What's common? Well, 2, they each have a 2. They each have a 3. Anything else? No, that's it. So my greatest common factor is going to be 2 times 3, 2 times 3, 6. So the GCF is 6. Greatest common factor is 6. Or I could write this as 18 is equal to 6 times 3, and 60 is equal to 6 times 10. And so you can see these are both the biggest common factor. And I can't really do anything else. That's basically it. What is the greatest common factor? Learning how to get there, factor them, find what's common, and then multiply them together. There are some you can do in your head. Let me do one of those that's a little bit easier. Let's say I have, what's the greatest common factor between 72 and 90? Well, I know 72 is 9 times 8. And I know 90 is 9 times 10. So I don't have to go 3 times 3 times 3. I can just say, okay, fine. 8 is 2 times 4, and 10 is 2 times 5. Okay, so my common factor is going to be 9 times 2, or 18. 18 times 4 is 72. 18 times 5 is 90. The greatest common factor, going back to here, factor first. What's common, multiply them together. That'll give you the greatest common factor. And I didn't have to break this down to 3 times 3 because I knew there was a 9 and a 9 in both. And that's okay to do. All right, that is primarily lesson number 13. Lesson number 14 coming on. I'm going to use a little bit of this. Lesson 14 has 2 parts. First part is get a new denominator, how to do that. And the second part is reduce a fraction. And what we're doing is we're doing this by algebra methods as opposed to how you may have learned it in 5th or 6th grade. So, for example, let's do some practice. 3. Well, that's 3 over 1. Okay, so what if I said, well, make 3 with a denominator of 18. So 3 is equal to how many 18ths? So 3 equals how many 18ths? So here's how you can do this. I'm going to write 3 over 1. Does that have an 18? No. What would make this have an 18 is if I just put an 18 there. Now it's 1 times 18. But if I take and multiply the denominator by something, I have to multiply the numerator by that same thing, because 18 over 18 is just 1. Well, what's 3 times 18? 3 times 18 is 56. So 3 is equal to 56 18ths. All right, let me give you one that's actually more of a fraction. So let's say I have 1/6, and I want to know that's equal to how many 18ths? Well, again, looking at this, I want this to look like 18, but to do that, I have to multiply top and bottom by 3 over 3, because that's just 1. Well, 3 times 1 is, so 1/6 is 3 18ths. That's how you do that one. Okay, second one is how to reduce a fraction. Well, this is using this thing that we learned last time, which was factoring. So let's say I have a number 36 over 72, and I want to reduce that. Well, what I want to do is find the greatest common factor of each and then cancel them, because, so for example, 36 is equal to 9 times 4, right? 72 is going to equal 8 times 9. Well, okay, 9 will cancel, but that's not the greatest common factor. If I really wanted to continue on it, this would be 9 times 2 times 2. And this would be 9 times 2 times 4. The greatest common factor is 18. 9 over 9 is 1, 2 over 2 is 1, and 2 over 4 is equal to just 1/2. So I can do it a couple of ways. I can just go, I can figure this out, or I could just recognize 36 over 72 is 1/2. I can factor it and cancel stuff, but I have to keep going until I finally get to the smallest amount. So let me show you what I mean by that. Let's say you've got a number like 30 over 45. To guarantee this works, I can say 30 is equal to 3 times 10. 10 is equal to 2 times 5. Those are now all the smallest they can get. They're prime numbers. 45 is equal to 9 times 5. But 9 is equal to 3 times 3. So now, if I wanted to, so it's 5 times 9 is 45. So now if I wanted to find what is this reduced, I can just cancel. 3 over 3 is 1. 5 over 5 is 1. So 30 over 45 is 2/3. So it always works if you prime factor them down. You can reduce this a little bit. I could say something like 15 times 2, that's 30. And 45 is 15 times 3. Those will cancel. Answer, 2/3, just like here. If I can factor them and find the greatest common factor, and I can do that in my head, you're allowed. If you can't, just do it this way, and you'll always get to the same answer. That's what this lesson is about, is getting you practice doing those. Okay, next, lesson number 15, last lesson of the day. Lesson 15 is going to be about long division and writing fractions as decimal numbers. So here's the deal on that. So let's say, for example, you have 3/8 and you want to turn that into decimal. Well, 8 goes into 3. Again, if you're good at this, that's fine. 8 goes into 3 0 times. So I put a 0 there and I put the decimal there. Okay, 8 goes into 30 3 times. 8 times 3 is 24 with 6 left over. 8 goes into 6 0 times. That should have worked out. But 8 goes into 60 8 times 7 is 56 with 4 left over. 8 goes into 40 5 times with nothing left over. Therefore, I am done. That's the answer, 0.375. That's long division. That's how you change a fraction into a decimal. Let's look at a different one. 1/30. Well, 30 goes into 1, 0 times. I put that 0. 30 goes into 10, 0 times. 30 goes into 100, 3 times. 3 times 90, and this gives you 90 with 10 left over. Well, 3 goes into 100, 3 times. 90 with 10 left over. 3 goes into that 3 times. And I end up with 0.0333 or 0.03 with a bar over it. That is how you would typically do this problem. Some of you would have moved the decimal to start with. That would have been fine. This is how you would write it, and that's it. So how this works itself into a problem is just you'll be given a fraction, turn it into a decimal. They will either say, give me the total decimal, or they'll say like round to 2 decimal places. Decimal places. What they mean by that is they go from the decimals, go 1, go 2. What would that be rounded off? And it would be 0.03. That would be rounded. The actual answer is much different, but if they say rounded to 2 decimal places, that's what they mean. Okay? Now, one more thing with that is if you know how to go from a fraction to a decimal, the question is, how do you go from a decimal to a fraction? So, for example, you have a number like 0.041, and they say, make that a fraction. These are a little bit easier. What you do is you look at these decimals and you go, this is the tenths, that's the hundredths, and that's the thousandths place, right? Tenths, hundreds, thousandths. Okay, well, this is 41 thousandths. The answer. That's it. So when you're taking a decimal going to a fraction, you read the number and anything down here, and then you would just change it into that. That's how you do it. And then you just write the number. So what about something like this? What about, let's say you have 3.104. Let's say change that into a fraction. Well, you could write it as 3 and 104 over tens, hundreds, thousandths, right? Or you could just write 3,104 over 1,000. So when you're, mostly you will do it this way, but that's okay too. 3 and that, or just this. Both work just fine. And that's about it. So hope you enjoy lesson 13, 14, 15, and I'll see you next time.